We've talked about the different kinds of chemical bonds. Now we're going to talk about them in more detail. So what is a chemical bond? Is the way that atoms or ions are attached to each other in a compound. And chemical bonds form because they lower the potential energy between the charged particles that compose atoms. Even in a covalent molecular compound, there are charged things, right? There's negative electrons, positive protons. And so a chemical bond will form because it lowers the energy. Most of nature is driven by this basic idea that things tend toward low energy. So as two atoms approach each other to form a compound, there's a complex set of interactions. You've got electrons repelling each other, you've got nuclei repelling each other, then you have electrons of one atom attracting the nuclei of the other atom. And so it's this kind of dance going on here. So the bond will form if the sum of those interactions results in a net reduction in energy. So the types of bonds, ionic bonds. Ionic bonds, as we learned earlier, are between metals and nonmetals. Metals have low ionization energies, and so they will lose electrons and form cations. Nonmetals have negative electron affinities. That means they release energy when you give them an electron. So the nonmetals gain electrons to form anions. When you've got a metal and a nonmetal getting together, the metal transfers the electrons that it's getting rid of to the nonmetal. As a result of that, you have oppositely charged ions and you have electrostatic attraction between those charged ions. So this table summarizes the three basic types of bonds. We're just talking about ionic right now. It's between metals and nonmetals, and the characteristic of it is that electrons are transferred. In a covalent bond, well, let's look at the table while we're here. In a covalent bond, this happens between two nonmetals, and the electrons are shared instead of transferred. Bless you. So the nonmetals are going to interact and share electrons. Nonmetals like to form negative ions, but when you just have two nonmetals, you don't have one that's willing to give up electrons, right? They would both like to get electrons, but nobody's willing to give one up. So they compromise by sharing. That's how I think of it. The shared electrons attract the nuclei of both atoms. And so here's one nucleus, here's another nucleus, here's our shared electron. Well, where is that electron most likely to be? If it's up here, we've got some attraction to both. If it's over here, we've got more attraction for this one, but not for that one. The most stable place is when that electron is in the middle, and you've got maximum attraction between the electron and both nuclei. So we find that those shared electrons will tend to be between the two atoms, and they're kind of holding them together. Any questions yet? And metallic bonding is really kind of weird. Let's see what that table says. Electrons pooled. Yeah. So metallic bonding, as the name suggests, occurs between metals, right? Metals lose electrons easily, but if you just have like a bunch of aluminum atoms, they're like, oh, I'd like to, ditch these 3 electrons, but nobody wants to take them. Well, they don't behave like the nonmetals where they're sharing. They just kind of let those electrons run wild. We say that they pool their electrons. So what does it mean when you pool your resources? You get together with your friends and you're going to buy a present for someone and you pool your money. You put it together, right? Right? So you put all your money together in a pile and then you can use it to do something. So in a metal, the atoms in the metal pool their valence electrons. So all the valence electrons are kind of put into this big pot you could think of, and it's for everybody to share. We call this the electron sea model. Okay, so those electrons are kind of like a swimming pool or an ocean, and so they're fluid and they can move around. So that doesn't make a lot of sense, I think. I like to think of, I've told you, I think of electrons as being like children, and the nuclei are the mothers or the families. And so I think of this as like a neighborhood where mom has sent those squirrely children out to play. Okay? So you've got the houses, and mom sent the kids out to play. This is like the world was when I grew up. We went out to play, and we'd come back when the streetlights came on. And mom didn't know where we were, and it was fine. Can't do that today, sadly. But the electrons are just out in the neighborhood, running around. And they could be anywhere. They're not like going off to China or something, or going to Los Angeles. They're in the neighborhood, but they're not necessarily at one particular house. We say they are delocalized. They're not attached to a particular house. They're able to move around the neighborhood. What holds the metal together is that the positive nuclei are attracted to this negatively charged group of electrons, and so they stay together. Does that make any sense? The good news is we do not have to have a great understanding of metallic bonding at this level. We'll just kind of leave it at that.